So we're still talking about Ipsec standards, and we talked about the difference between transport mode and tunnel mode. Transport mode is used to create a tunnel between two hosts, and in that case, the original IP header is exposed. It's not encrypted, but we add the ESP header and the AH header after the original IP header, and there's only one single IP header. In the case of tunnel mode, on the other side, the tunnel mode hides the original IP either for the sender and the destination, and it adds an outer IP header. The outer IP header will be for the entry firewall and the output firewall, right, of the tunnel. Or firewall, I mean router, okay. So in that case, the original IP header together with the payload of the data is all encrypted. And this is used typically to create a tunnel between two networks or two routers or two firewalls, or between a host and a network. So in the standards, they define, as we said, the AH is used for authentication, and as we said, AH was part of Ipsec version 1, okay? And ESP is for encryption, okay? Encapsulating protocol. So, however, as we said, in Ipsec version 2, starting Ipsec version 2, the ESP integrates the authentication as part of the ESP header, in which case ESP is used for both encryption and authentication. But however, the AH has been left for backward compatibility. So ESP may in fact be used for both encryption and authentication, and in that case the AH is optional, okay? So for AH, which is for authentication, in transport mode, security authentication, or security association, sorry, we'll talk about security association in a minute. The authentication includes the IP payload and the selected portion of the IP header. This is for authentication, not for encryption. In other words, as we said before, we have the IP payload, and again we add the AH, okay, and we have we have the original IP, ماشي, header طبعا, original IP header, okay. So remember, we add the AH. The authentication includes everything. This is when you calculate the message authentication code. When you calculate the message authentication code, you calculate it based on the entire header and the payload. However, when you encrypt only the payload. So this is for authentication, and only this is for encryption. Okay, but of course the original IP header is left exposed because you have to use it for, especially this is in the transport mode. You have to leave it exposed for the routers, because the routers, they need to do routing, and for routing they need the IP header. Okay, so it's left exposed. This is for the transport mode. For the tunnel mode, you have to add another outer IP header. In which case the encryption includes also the original IP header. The original IP header is also encrypted, because the outer IP header will be used inside the tunnel for the routers to perform routing. So the routing inside the tunnel will be done based on the outer IP header, not on the original IP header. The original IP header shows the source address and destination address of the hosts, right? But we don't need this inside the tunnel. Inside the tunnel, you don't need this. So you see that for authentication, you always have to include the header. But when it comes to encryption, encrypts the IP header only. Forget about IP version 6 extension. IP version 6 extension, we're not going to talk about IP version 6 for IPsec because it's much more complicated. But if you want to understand what this means, for IPsec, if we assume that this header is IPsec, if you remember in the IPsec there was a field in the header called next header, remember? In network 1? Yes. We studied next header may in fact point to another IP header, right? Next header may in fact point to another IP header which is version 4. So if IP6 points to extended header, then the extended header is going to be encrypted. That's the only condition. But in normal cases, the encryption only includes the IP payload. But if there is any IP version 6 extension, it may be encrypted as well. Okay? But in normal cases, we encrypt only the payload and leave the IP header exposed so that routers may perform routing. Now, in the transport mode, the original IP header is used and there is no outer IP header. It's one IP header, and in that case, it should be left exposed. It should not be encrypted. But in the tunnel mode, we have the outer IP header, in which case the original IP header is encrypted. واضح كده؟ And of course, we have ESP, we have the option to use ESP both for encryption and authentication, in which case we encrypt the payload and any IP version 6 extension, forget about this, and then authenticates IP payload, ماشي? But not the IP header. If we use ESP for both encryption and authentication, in which case we authenticate only the payload and we encrypt only the payload. Okay? But if we use AH for authentication, we include the IP header in the signature where we calculate the message authentication code. Okay? So we'll talk about this in terms of encapsulation, so it becomes clearer. So now, this is the architecture of IPsec. This is the overall architecture of IPsec. It starts from what we call security policy database. As we said before, security policy database, whenever any traffic comes in, okay, you should define a rule based on which this traffic will have to be we will have to create a tunnel for this traffic, or possibly bypass this traffic from any tunnel that exists, right? As we said, we can feed that traffic into the tunnel, or we can bypass this traffic from the tunnel completely. So whenever any traffic comes in, okay, the first thing you ask yourself is that, is there any rule in the policy database for that incoming traffic? A traffic is defined by a combination of source IP address, destination IP address, the protocol used in the header, whether it's TLS, ICMP, things like that, or any protocol, right? Or TLS. Because TLS, we'll talk about TLS next. TLS is a transport layer security protocol, right? So all the upper layer protocols for me are exposed and I can see them. So now, based on a combination of source IP, destination IP, port, protocol, things like that, I can define a certain rule that, okay, so this traffic needs to be used as part of a tunnel. Okay? So here, we need to define the security association for this tunnel, okay? So if I need to feed that traffic into a tunnel, then I need to have a security association which is defined in another database. ماشي? This security association database contains بقى the details of that security association, which means that this traffic will have to use بقى ايه؟ will have to use مثلا RSA for encryption, HMAC for HMAC ولا كده for message authentication codes, and it has to use these particular keys and so on. So all the specification for the tunnel will be stored in that security association database, and we'll talk about all the fields in this security association in a minute. ماشي? So from this security association, I can now provide ESP protection for this traffic. ESP protection, which means that this traffic that will be encrypted and will be authenticated, and everything will be going through that tunnel. If the incoming traffic, there is a possibility that the incoming traffic does not have a security association yet, right? Which means that the security parameters have not been established yet. Okay? Which means that I need to perform authentication similar to the authentication process that we have done for network access or so on. Then I need to go to IKE, okay, and perform some handshake to agree on security association, new security association. Once I agree on a new security association, I put it in the database here, and here I get the primary key of that security association, and I put it in the policy database. So whenever this traffic comes in, please apply this rule, which includes this security association in the database. Get all the parameters from this security association database to know exactly what are the parameters of that tunnel. So perform the protection for that traffic, and if you need to establish a new security association, then you need to go to IKE, which performs some authentication messages to create a new security association. Okay? So that's the sequence. Incoming traffic, you have to apply a rule. And the rule could simply be discard that traffic or bypass this traffic, which means that there's no tunnel. Just send it to the internet as is. So no SP header, no AH header, nothing. خلاص. The traffic will go through very smoothly, and there is no Ipsec in the picture. ماشي? Or I need to protect that traffic. Okay, so protect that traffic means that you need some security association. A security association, this is a context where it stores all the security parameters, including the keys and what technique is going to be used for encryption, what technique is going to be used for authentication, and so on, which is going to be stored by the ESP header and AH header and so on. Okay? Type. I need to protect that traffic, but I don't have a security association yet. Okay, so go to IKE to establish a new security association. Once you establish a new security association, put it in the database, point to it in the policy database, and your job is done. Okay, so now any traffic comes in, it will go and it will be protected. So this refers to the tunnel, and the tunnel is defined by ESP header and optionally the AH header. واضح كده؟
What's the IKE? Is it the
Internet Key Exchange. Remember we talked about this in network access security, right? As one of the options for establishing the user authentication and key management, right? So here بقى we talk about the specifics of this IKE. We'll talk about these specifics. So IKE, the job of IKE is to establish what we call a new security association. A security association is just you can think of it as a data structure, okay, that has all the parameters you need in order to establish this tunnel, including بقى what technique is going to be used for authentication, what technique is going to be used for encryption, what are the keys that are used in each case, what function is going to be used for a pseudo-random function to generate مثلا IVs, things like that. Okay. How are we going to mitigate replay attacks? How are we going to provide padding? We'll talk about this in details. So all of this is stored in a specific data structure. We call it security association. So IKE will establish that security association for the first time. Once it performs that security association, then it puts it in the database and it goes out of the loop. خلاص. Okay? But of course, the security association, as we have talked about before, any kind of security context, it has certain lifetime and it has to be renewed every time, right? So we have to renew that security association from time to time. Okay? This is the overall picture, but we'll talk in details about this in the coming slides. Don't worry.
The stuff that you bypass, would it be the stuff with the TSL and handshake already? Or?
Well, it's up to you. So you can define whatever rules you want to apply for certain types of traffic. One logical example that we talked about is that if the incoming traffic is TLS, okay, is TLS, so the user typed the HTTPS, okay, so everything is encrypted already, okay, to go to the website. So why duplicate the effort? Okay, so if the incoming traffic is TLS, then bypass it. In fact, some traffic that requires message handshaking for IKE, this should be bypassed from any tunnel because this is actually used to establish security association. So it does not need to be fed in a tunnel. Okay, so even the messages that IKE is used for exchange is similar to, remember when we talked about the radius server, we said that the port to the radius server is uncontrolled port because this is actually used for authentication. So similarly, these messages for IKE, these messages are used to establish a new security association. So you do not have to really put these messages in a tunnel. That does not work this way. So anyway, so we'll talk about this in details in the coming slides, and we'll see how these rules are applied. The most important part of IPsec is what we call security association. Security association, as we said, you can think of it as a data structure that stores all the information about the parameters that you need to use in order to establish that secure tunnel. Okay? What technique is going to be used for encryption, authentication, IV, creation, key management, replay attack, padding, all these parameters are going to be stored. Okay? So this security association needs to tie or associate the incoming traffic to a particular security association. So in other words, the incoming traffic should be mapped to one of the existing security associations, or you need to trigger the creation of a new security association. So there is a primary key for any security association. Okay? So this primary key is called security parameter index. This is the primary key, which is the unique identifier of this security association. The content itself is in the next slide. We'll talk about what this security association includes. Okay? Type. So this primary key, it's mapped to the traffic, the incoming traffic, okay, based on other unique identifiers. Okay, so a security protocol identifier, whether it's AH or ESP. So this is like a flag that says that this security association uses ESP or uses AH or uses neither. What is an example of neither AH or ESP? An example is like IKE messages. The IKE messages, they are not data messages. These are control messages. So in that case, they will not use AH or ESP. ماشي? And the IP destination address. This IP destination address could be the destination address of the ultimate host, or in the case of the tunnel mode, it's the IPA of the router, of the output router, يعني of the termination router in the end of the tunnel, right? Okay, so these are the unique fields in the security. We didn't talk about one very important thing. The security association is a one-way logical connection, security connection. Huh? It's a one-way logical security connection. Why is it one way? Why is it one way? This is very important. Remember, we talked about IP. IP itself is a connectionless protocol. Huh? Oh, we're combining network one with security. This is very important. IP is a connectionless protocol, which means that there is no bidirectional connection. And TCP is connection oriented, صح? So TCP provides bidirectional because there is a concept of a connection. So you have to establish a connection, and then both of us will talk to each other. صح? But IP does not recognize the concept of a connection, right? So that's why there has to be a logical connection in one way and another logical connection in another way. So if host 1 talks to host 2, it will send stream of packets which they do not have to follow any connection, right? So we cannot establish a two-way security association because IP does not have any connection. So stream of packets following certain direction, they will use one security association, okay? If we want to communicate back, then we have to establish another security association altogether. ماشي؟ يعني this has to be very clear. So when we represent it now, so we have, let's say we have a host here, and we have a network here, okay? And this is host 1, and this is host 2, and they communicate to each other through the public network. They communicate through a tunnel, okay? So there is a tunnel between these two hosts, okay? So a tunnel, it combines, it actually connects host 1 to host 2, right? But remember, underneath we use IP, and IP, in fact, it uses like stream of packets, or it sends a sequence of packets. And in fact, these packets, remember, these packets, they can in fact follow different paths and different routers. One packet may go this way, one packet may go this way. مش احنا we talked about IP like this, صح? Why? Because IP is connectionless and it's unreliable. Huh? صح? IP is connectionless and it's unreliable, which means that packets may take different paths, صح? And packets, they may not actually reach to the other end. They may not reach to the other end. Okay? So that's why we cannot define a security association, okay, bidirectional between host 1 and host 2. Packets going from host 1 to host 2, they will follow certain security association. Packets coming from host 2 to host 1 or to anything, they will follow different security association. Imagine? That's why security association is one-way logical security connection. Okay? طيب, another very important implication of the fact that IP is connectionless and it's unreliable is that the packets that are going in order, they may not arrive on the other side in order, صح? Right? Because they follow different paths. There's no guarantee that the packets going in a certain order that they will have to follow certain routing path in the network. I cannot guarantee this. صح? So the packets may arrive unordered. This is always the implication of any protocol that's connectionless. Packets are unordered. Okay? In TCP, we'll study it in the next chapter. In TCP, we see that the security context is different. Security context is bidirectional because there is connection. This is the implication of doing security in certain layer. You have to follow the characteristics of the underlying protocol that you are using. Type. So, but now we talked about the sequence number, okay? And this sequence number is set in every packet, right? But these packets may arrive unordered, right? So the current counter is not actually in order. صح? So the counter that you are setting in the packet, it will not be in sequence. Because the packets on the other end, they will arrive unordered. Okay? So that's why the security association uses a technique for mitigating replay attack. It's not only the sequence number. It uses... But the content of the security association includes all of this. Okay, and other fields that we don't have to worry about. ماشي? So what is the function of each field? This is very important. Of course, security parameter index, as we said, this is the primary key. So the security parameter index is just a unique identifier that identifies this security association. Okay, security association is like one row in a table of a database. ماشي? It contains all these fields. Type. One field is what we call the sequence number counter. Okay, sequence number counter is a sequence number that we assign, okay, to the packets that are coming in. Okay, and the current sequence number counter is stored in the security association. So why do we need to have the sequence number counter, you think? Why do we need to have a sequence in every packet?
So track if anything gets dropped.
This is not my function. Remember, here I'm a security context. I'm not a protocol, or I'm not aiming to provide reliability or something. That's not my job. This is the job of IP, not my job. Okay? Here we are IPsec. We care about security, not reliability or no retransmission. I'm not gonna do retransmission here. Okay? It's not my job. This is IP job. But why do we need to have sequence number counter? Is to mitigate replay attack. Remember we said that I know that, everything, this is gonna be encrypted, by the way. This is gonna be encrypted. So if I encrypt the whole payload, right? And then I'm gonna take a copy of it and then replay it again. Okay? This is one type of attack. صح? A replay attack is one type of active attack. So if I don't have a timestamp or a counter that's encrypted as part of the packet, then I will allow anyone to take a copy of the encrypted data and replay it again and again and again and again. Okay? But then every time I generate a packet, if I put that sequence number and this sequence number is encrypted, then if someone tries to replay it, at the output on the other side, okay, I'm gonna recognize this as a duplicate packet, and I'm going to discard it. And also, I may actually take a further action. I may say, okay, so that might be an indication that somebody's trying to replay packets, in which case I need to do something about it. So if somebody's trying to attack, maybe I can provide some sequence counter overflow. So I can say counter overflow معناها ايه? I reset the counter, okay? Because somebody is trying to replay that packet, so I will reset the counter, and in some cases it may lead to reset the entire security association. Okay, so we'll talk about some rules for this. So the sequence number is for mitigating replay attack. But the problem here is that, remember, here different fields. It uses the sequence number counter, صح? But the sequence number, if I see a number which is different from the current sequence number, that doesn't mean that this is a replay attack regardless. No, there has to be a replay window. And we'll see that technique in the coming slide. So just the fact that you receive a sequence number less or more than the current sequence number, that doesn't mean that this is for sure a replay attack. So, because IP does not guarantee that sequence. So let's agree on the fact that the current sequence number, the current sequence counter there is important, but that doesn't mean that anything other than this current sequence number is going to be a replay attack. No, we have to allow a window of sequences. A window of sequences. The window technique is used على فكرة not we talked about window technique for what فاكرين؟ Where did we study the window technique before? In what? In network 1, yes. Yeah, network 1 كان في ايه؟ كان TCP, yes. TCP uses window technique for flow control. ماشي؟ We also, I'm not sure, you are computer science, so maybe you didn't study that well, but in network 2, we also teach window technique in the data link layer. Okay? Because again, data link layer provides flow control. Okay? But here, it's used for mitigating replay attack. Okay? But the same concept. It's like you have to maintain the current sequence number, but things are not guaranteed to come in sequence. So we have to allow for a window. This window represents how unreliable IP will be. Okay? So it's like if say مثلا the current sequence number is 4,000. Okay? ماشي? This is the current sequence number that's stored in the security association. Okay? طيب, what if you get 3,900 or 3,990 مثلا? Does that mean it's a replay attack? Not necessarily. Maybe yes, maybe no. Maybe yes. هو احنا قلنا replay attack is what? Replay attack is somebody who got a copy of a packet that's encrypted. Okay? Maybe that packet has the sequence number of 3,990. Okay? And he tried to replay it again. Okay? So after you have sent multiple packets after this, okay, somebody is trying to replay again the same packet later on. Okay? So I need to mitigate this. But at the same time, unfortunately, IP is unreliable. So I may in fact get a legitimate scenario where the packet that has this sequence number is really a packet that went through a longer path in the network and it arrived late. So it's tricky now. فاهمين متابعين الموضوع؟
We need both the sequence number and
Yes, so that's why we need another parameter which we call it anti-replay window. Okay? And we need to have another parameter as well, which is a flag whether this packet has been received before or not. We'll see about the entire mechanism, but the important thing here is that replay attack cannot be mitigated with just a simple term, with just a simple parameter like the sequence number counter. That's not enough. We have to have a full window technique. A full window technique. Okay, similar to what TCP uses, but here the logic, you see, the logic here is different. The logic is totally different. Because this is not for flow control. This is for mitigating replay attack. Okay? This is how the standard developers, they develop these things. They think about it, they brainstorm, they see what is the objective. The objective here is to mitigate replay attack. Yes, okay, so IP is unreliable, which means packet will arrive unordered. So we cannot rely on one simple parameter. So we have to have a window. Okay, so, but this window is not what is the logic based on which I say, So this packet is inside the window. Should I allow it all the time? Well, there is a condition. Okay. طب what if it's before the window? What is after the window? When do I slide the window? ما هو window معناها we have to slide. صح? So there's a whole mechanism that has to be in place to mitigate the replay attack. It's not simply a sequence number. As we have talked about we will talk about it in the next chapter, TCP, اللي هو TLS يعني. But TLS, the job here is much simpler. Why? Because on one hand, TLS is application to application communication. So it's actually one traffic. The problem here is that this IPsec is going to be implemented in the router. So you have يعني tons, hundreds, or maybe thousands of traffic that is coming to this router. صح? Some of this traffic may actually use TCP, ICMP, UDP, TLS, HTTP, many things. صح? But TLS, the job is much easier because it's application to application. Okay? So that's one good news for TLS. The other good news is TLS leverages TCP, and TCP is connection oriented, and everything is by default guaranteed to be ordered. صح? So you will see that TLS uses only one sequence number to mitigate replay attack because everything is in order. Because TCP is reliable. واضح الموضوع? Okay? So this is the implication that when you implement a certain security protocol in a certain layer, you inherit the characteristics of the protocol in that layer. واضح? So here we are inheriting the characteristics of IP. Okay? So we have to deal with that. So IP is connectionless, it's unreliable, and that's why we have to do all of this. The other thing is IP have to accommodate diverse set of traffic, whether TCP, ICMP, UDP, TLS, HTTP, many things, right? So that's why you see that there is a security policy database. This will not exist in TLS, as we will see. TLS does not have the security policy database, it does not have all of this. It's much easier, but IPsec has to be complicated because it has to deal with lots of traffic, and it has to have different security association for each type of traffic. That's why it's complicated. You have a question?
So, Doctor, if there is a packet got lost, it will not guarantee it will be sent again because.
Yes, but IP is unreliable. IP does not guarantee. احنا قلنا best effort. IP is best effort, صح? So the packet may get, in fact, lost. Okay? If it gets lost, that doesn't mean that this is the end of the story. IP works underneath TCP, so TCP might retransmit it. So when it retransmits that segment, it becomes an IP packet, and then we'll deal with it. ماشي? Then it will get back another sequence number and so on, and will mitigate the replay attack and so on. But IP itself does not provide, and of course IPsec. ما حدش يقول لي IPsec will retransmit. IPsec ملوش علاقة. IPsec the security protocol. It's not a reliable data protocol. It's not meant to perform delivery mechanism. This is to perform a security mechanism. It's not the job of IPsec to retransmit. And it's not even the job of TLS to retransmit. ماشي؟ إنما these are security protocols. Okay? طيب, so the security.
So since there's chance of packets being lost, does that mean each packet is encrypted independently?
Of course.
Right.
Of course. Each incoming packet will have to be encrypted. But طبعا you have the same key. Okay? For a certain period of time, not necessarily for everything. For a certain period of time, you have one key, so every incoming packet will have to be encrypted.
And they're numbered on the other side.
They are numbered on the other side, but this sequence number here is not going to be stored in the packet.
Right.
Okay. So it is yes. So it's going to be encrypted in the payload, and you cannot see it. So when you arrive on the other end, okay, you have to mitigate the replay attack somehow. And for mitigating the replay attack here, we need 3 fields. So this sequence counter overflow it's like a flag to indicate that, okay, so I detected a duplicate packet. I detected a duplicate packet. Okay? معناها, so this packet seems to have a sequence counter which is some way in the past, outside the window completely. So this might indicate some fishy things happening. ماشي? This fishy thing that's happening might indicate you have to renew the whole securitization. You have to reset the counter so that you confuse any kind of crypto analysis or any kind of attack. Okay? But this is an indication that I detected some discrepancy, that due to the window technique that's happening, the window technique is violated. So there may be something happening now. Okay? And it's up to the rules in the policy database how to react to this. Maybe the rule will be renew the entire securitization, which means you have to go to ITE and ask ITE to provide a new securitization. So ITE is going to exchange another securitization, which requires a new IV and new generated keys. Everything will be new. Okay? So we'll see in details how the replay attack is done and how ITE performs that securitization creation for the first time. So we have, of course, AH information and ESP information. So this is for authentication, this is for encryption. And again, we'll talk about each of these. By the way, that's why I said this is a data structure, because each of these is a set of fields. And this is the lifetime. As we said, nothing is forever. So the securitization itself has a certain lifetime. So after certain lifetime, you have to renew that securitization. Even if there is no counter overflow, even if there is no replay attack or something, you have to renew it every time. You have to renew it every lifetime. Okay? So the lifetime typically it could be like 5 minutes, 10 minutes, or something like this, and then you have to renew the securitization again. So you have to go to ITE and ask ITE, please generate a new securitization from scratch. And as we said, there is the protocol mode, and this protocol mode could be transport mode or tunnel mode or wildcard. Wildcard, as we said, wildcard refers to any kind of non-data messages. Like, for example, control messages for ITE or something. You can use wildcard for this, because it does not have to go through the tunnel. It does not have to go through the tunnel mode or the transport mode. And there is another important parameter called path maximum transmission. Path maximum transmission. فاكرين maximum transmission؟ حد فاكر كم بيستخدم فيه؟ So if you have a router and you have a certain network access technology here, and you have multiple hubs, right? So if you have, مثلا here, Ethernet, okay? Ethernet using maximum transmission unit of, حد فاكر؟ 1500 bytes. Okay, this is the maximum transmission unit for Ethernet, مثلا. And this router connects this network with another network, and this network happens to be wireless. And the maximum transmission unit is like 500. فاكرين السؤال الشهير اللي كان بيجي دايما في المتر؟ So what do we need to do here؟ حد فاكر؟
It's not an issue. You have to send by packets 500, 500, 500.
Right, so we call this fragmentation. صح? We call this fragmentation. So we have to divide a big packet into smaller fragments. صح? And each fragment is going to have a certain identifier which points to the right, and so on. Okay? So we in IP, fragmentation is supported. يعني it's part of the protocol. The problem now if you have a tunnel, imagine like if you have a tunnel between these two routers, okay? Well, you can still perform some fragmentation inside the tunnel, but when you do fragmentation, you require here like Ipsec to say that these fragments, they still need to use the same security association and so on. It will complicate things, okay? So it's not desirable within the tunnel to do fragmentation. It's not desirable, okay? But sometimes we have to. We have to. What if the packets are going this way and the length is 1500 and then it goes to here and the maximum transmission unit is 500? I have to do fragmentation, okay? So that's why what they do is that as part of Ipsec, you have to negotiate with the end router to see which part of the network has the minimum maximum transmission unit. The minimum maximum transmission. So here is 1500. Here is 500. Here is 2000. Okay, so which one is the minimum? 500. Okay, so the path maximum transmission unit is going to be 500. And what this means is that this router is going to do the fragmentation at the beginning of the tunnel, okay? So that you don't have to do further fragmentation inside the tunnel. كلام كبير صح؟ واضح يعني؟ اتفضل.
دكتور, the path itself is not هو مش ثابت يعني ممكن.
No, it's fixed.
الباث نفسه fixed.
الايه؟
يعني ممكن يكون الباكت يمروا بأكثر من طريق.
Of course, yes, of course, but you have to specify the maximum transmission unit for all the hubs, from the first router all the way to the end router on the other side. Okay? So if what you're saying is that maybe the packets will go this way, right?
Yeah.
So you have to specify, you have to define the minimum maximum transmission unit in all these access network technologies, right? And by the way, as I said, fragmentation can still be done inside the router, inside the tunnel, can still be done, but it makes things more difficult. So that's why it's better to negotiate a path maximum transmission unit at the beginning, okay? A path, okay? Like the minimum maximum transmission unit along that path, okay? But if you have to, you will have to perform some fragmentation inside the tunnel, okay? But this will have to be addressed separately. But here, usually we maintain in the security association, remember, in the security, not in the packet, in the security association, we maintain a maximum transmission unit for the entire path, so that we perform fragmentation only at the end, at the entry router, okay? And we perform defragmentation at the exit router, and that's it. Imagine?
So the first step, I have to look at every possible path.
Right. Yes, and select the minimum. Yes, and select the minimum maximum transmission unit along that path, and store this in the security association. And this will be a way for the entry router to perform one single fragmentation based on this minimum. So it knows or it guarantees that يعني إيه, along the tunnel, even if you go through any route, that there will be no fragmentation inside the tunnel. Okay? طيب. So these are the fields, and actually there are some other fields, but these are the most important ones. ماشي? We'll talk about how they are used in more details. So, as part of the architecture, we talked about the security policy database. This is very, very important. Security. خلاص. طب okay. We'll stop here. إن شاء الله.